Hey everyone, and welcome to this Explainer, AI Fundamentals Source-Based Model Video Overview. Today, we're jumping right in with one absolutely crucial question. How can we use actual source evidence to build and evaluate a conceptual model of an AI system? We aren't just going to guess or make things up today. We're going to build a solid model using strict evidence from authorized sources. Let's get started. Here's a quick look at our roadmap for this Explainer. First, we'll tackle the magic brain misconception, then build with source evidence, put our model together, give you a chance to test it, review the evidence, and wrap up with a final takeaway. All right, let's dive into section 1, the magic brain misconception. If you ask people how artificial intelligence actually works, you'll hear this one massive misconception over and over again. A lot of folks think an AI system is basically this independent magic brain. Because it gives us answers so incredibly fast, there's this assumption that it just magically knows the right answer, and because of that, whatever it spits out should be automatically trusted. But we're focused learners, right? We don't rely on magic. We need to look at what the actual source evidence says about what's really going on under the hood. That brings us to section 2, building with source evidence. So according to our evidence, AI definitely does not have magic intuition. Our How Artificial Intelligence Works source from OECD.ai states that an AI system relies on things called sensors to collect raw data inputs. And if we cross-reference that with the grade band progression charts from AI for K-12, it aligns perfectly. This is exactly how computers perceive the world, using data provided by machines or humans. Next up, we have the second element, operational logic. This is huge because it means the so-called brain is really just operational logic interpreting all that raw data. It takes the information, processes it for a specific set of objectives, and then gives us an output. That output usually takes the form of a recommendation, a prediction, or a decision. In fact, that OECD.ai source specifically points out that the real power of an AI system lives right here, in its operational logic. Finally, we have the third element, actuators. Once the operational logic actually makes a decision or prediction, the actuators take that output and use it to change the environment. And just like those sensors we talked about, actuators can be machines or they can be people taking action out in the real world. Let's move on to section 3, putting the model together. When we map this all out based strictly on the text, it is amazing how simple and clear this linear model is. Data flows in from sensors as inputs, it gets processed by the operational logic to meet a specific objective, and it results in an output from the actuators. There's literally no magic involved. It's just a structured system reacting to data. But hold on, we aren't completely finished yet. Remember that big myth we talked about? The idea that we should automatically trust whatever the AI outputs? Well, the AI Risk Management Framework from NIST, alongside the NIST AI RNF playbook, explicitly gives us guidelines to help incorporate trustworthiness into these systems. This means we absolutely have to build risk management and human review right into our model. We need a way to evaluate the AI, rather than just blindly accepting its answers. To really understand this, let's apply our evidence-backed model to a worked example directly from OECD.ai, an autonomous driving system, a self-driving car, basically. The inputs collected by sensors here would be machine-based historical data and human-based driving rules. The operational logic is working to achieve the objective of getting you from point A to point B safely, mostly by predicting obstacles. The output from the actuators, those are physical decisions, like hitting the brakes or accelerating. And finally, applying our NIST AI Risk Management Framework source, we have to add an evaluation step, human review to manage safety risks. Because, let's face it, a car making a wrong prediction is incredibly dangerous. Okay, on to section 4, your turn, test it. Now we're going to use another awesome example straight from that OECD.ai source, a credit scoring system. This is an AI that helps decide if a person should get a bank loan. Here is your task. First, identify the model's components. What are the inputs, the logic, and the outputs? Second, if someone claims the system is flawlessly fair, is that conclusion actually supported by our evidence, or does it go beyond it? Third, identify a limitation that would require human review. And finally, propose a revision to the model and justify it using the evidence we've covered today. Go ahead and hit pause on this explainer right now. Grab a piece of paper, test your knowledge, and try building your own source-based model. When you're finished, just hit play and we'll review it together. Welcome back. Let's get into section 5, reviewing the evidence. Okay, first, let's break down the components of that credit scoring system using the OECD.ai text. For the inputs, you should have identified machine-based inputs, which is all the borrower's data, and human-based inputs, which are the actual rules for borrowing money. For the operational logic, the system is interpreting that data for one clear objective, deciding whether to approve or deny a loan. And for the outputs, the system is providing recommendations in the form of credit scores. Next, let's talk about what's actually supported by our evidence. It is totally supported that the AI generates a score based on data. But what if someone claims that score is flawlessly fair? No way, that goes way beyond the evidence. Nothing in our sources guarantees a perfectly fair result. Because of this limitation, you should have proposed a specific revision to your model, adding a step for human evaluation. You can completely justify this using the NIST AI Risk Management Framework and the NIST AI RMF Playbook. They literally tell us we have to actively manage risks and incorporate trustworthiness. We definitely cannot just assume a bank's AI is perfect. And that brings us to Section 6, the final takeaway. The absolute most crucial point from this entire explainer is this: a really useful source-based model helps us understand complex technology without falling for myths. It identifies all the important parts, the sensors, the logic, the actuators, and how they relate to each other. It ties every single part directly to reliable evidence, like those OECD, AI 4K12, and NIST reports. It explicitly acknowledges that these systems have limitations, and most importantly, it helps people evaluate an AI output for risk, rather than just accepting it automatically like it's some kind of magic brain. Before we wrap up, I want to leave you with one final question to think about. Whether it's the algorithms recommending your next video or the filters processing your photos, what other AI systems in your daily life might require you to step in, evaluate the evidence, and apply human review? Keep thinking critically, always rely on your sources, and never stop questioning the operational logic happening all around you. Thanks so much for joining me for this explainer.